We often associate electronic waste with the devices we throw out in favor of upgrades and replacements, but forget about the waste that is produced from just making the devices themselves. Electronic manufacturing consists of many processes, each of which generate wastewater with a unique composition of heavy metals. The most common treatment method is to precipitate the heavy metals out into a toxic sludge that poses major health risks to humans and wildlife. One process used in the industry, called metal finishing, produces approximately 150,000 tons of this sludge in the European Union alone every year. Companies have developed remediative processes to try to reverse the detrimental effects of heavy metal pollution from this sludge. But what if there was a solution that not only prevented heavy metals from ever entering the environment, but also recovered them for reuse in the industry? Waterloo iGEM presents REMINE, a packed column bioreactor containing cellulose and a fusion protein. The fusion protein is composed of a cellulose binding domain and a metal binding domain. As the wastewater flows through, the dissolved metal ions bind to the fusion proteins. By changing the chemical environment of the column, the metal ions can be recovered into a pure solution for reuse. REMINE can also be customized for any electronic manufacturer. REMINE utilizes molecular dynamics and protein structural modeling to increase the affinity of the fusion proteins for specific metals found in the wastewater. Additionally, with REMINE's process design tools, the specifications of the REMINE system can be determined to meet local regulations. REMINE not only adds a new revenue source from the recovered metals, but also decreases the need to mine for new metals. With REMINE, the electronic industry can continue to grow in Canada and the rest of the world while reducing its impact on our environment and health.